Early on in the star's life, lots of changes as it's forming, but once it gets kind of going and it reaches what we call the main sequence, stars are fairly steady. Now, you are right that the sun was less luminous in the past by about 75%, and that is would certainly have affected the beginnings of life on Earth. But the Earth was still close enough to the sun to have water in liquid form. So if the Earth started out where Mars is today, well, maybe it wouldn't have done so well. If it started out where Venus is today, well, maybe it wouldn't have done so well. And there are some other factors here that kind of complicate things. So the greenhouse gases are another major player in the climate of Earth and the climate of any planet. If you have lots of carbon dioxide in the atmosphere, that can trap the radiation from the sun to the surface and heat up the planet a bit. Now, in fact, people say greenhouse gas is a bad thing, but if we didn't have the greenhouse gas, CO2, in our atmosphere, we would actually be too cold to live. So there's enough heat trapped now to keep water in liquid form. The greenhouse gases can change, of course, with activity of volcanoes. Volcanoes emit a lot of carbon dioxide, and there have been periods in the Earth's history where there's been a lot more carbon dioxide in the atmosphere than there is now. There's a complicated interplay with the oceans and how much carbon dioxide the oceans can draw down through their plant life. So the carbon dioxide content has fluctuated throughout time. There's some other things going on astronomically. The Earth's pole isn't always pointing in the same place, it wobbles, so there's a cycle there. How elliptical the Earth's orbit is changes slightly, and so there's another cycle there. These are called Milankovitch cycles, which change the duration of the seasons and the intensity of the seasons. Now that can also have, of course, a profound effect on the Earth's climate. There's another thing where the Earth's axis tips more or further from the sun. If it's more pointed at the sun, you have hotter summers and colder winters. If it's pointed directly perpendicular to the orbit, there's no summer or winter at all. So these astronomical things can also influence the Earth's and a planet's climate and its propensity for life. At the end of the star's life, then it's all over. So what happens in a low-mass star like the sun or a low-mass star will shed its atmosphere. It will swell up to a red giant and then a super red giant phase where it is hundreds to thousands of times more luminous than it is today, and it grows in size. The sun will grow to about the size of the Earth's orbit late in its life as it runs out of its hydrogen fuel. Now, if you think of what it would look like on Earth, that would mean you would have a red-hot object filling half the sky. The Earth would burn into a cinder. Then the sun will, once it runs out of its helium fuel, will contract to a tiny white dwarf, which is something about the size of the Earth, glowing ember. It would just then lose all of its heat and will fade like a coal in your fireplace. So there's no energy at the end of the star's life, and things will get very cold. So the Earth will fry and then freeze. Now, if it's a more massive star, say 8 solar masses or more, it will blow up as a supernova and blow the planet to bits, or at least incinerate the surface. So it's bad news toward the end of any star's life. Now, the good news is we have another 5 billion years to sort it out. Presumably, we'll figure out what to do, build enough spaceships to get people to the next star or to a more distant planet, and save humanity that way.